Good afternoon, my name is Avi Kantha, and today I'll be doing my Physics Lab 2022-2212 lines of charge. So for introduction, this lab aims to show the interactions between charge tape and to finally count electrons lost in tape using experiment. This is a continuation of Lab 1. We'll compare differences with Lab 1 by using the lines of charges method. The object will be observed as a sharp change on tape B, and the glow script will be used to make a model interaction between two tapes. Systems, U tape, surroundings, and everything else. Some important laws are the Newton's second law, Coulomb's law, and gravitational force. So Newton's second law basically states that F equals ma, and we also use the momentum principle. Coulomb's law states that the charge force is k times the two charges over the distance between the charges squared times the distance hat, and then that's the gravitational force formula, which is negative g m1 m2 over r squared times r hat. So this is a little preview for results. This is our givens for Lab 1. So the length between two tapes is 0.03. I added that because I didn't have it on here earlier. But the main ones we need for this one is tape mass, tape length, and that's it. So this is how we estimate excess charge back in Lab 1. So what we did was that we used so we found the gravitational force. We set it equal to electric force because it's floating. We found the electric charge, and we found the electrons lost. For the next one, we don't need the electrons lost. We just need to find the electric charge. But now we're using the lines of charge method. So here we use to find the force of the electric charge, and we set it equal to the rod formula, and then from there we get the charge to equal this value. And now we make a closed group code. What we do in the top left, we have our constants that I showed earlier. Down here we have our actual electric field formula below the constants. To the right of the constants we have our actual lines of charges method, which is done using the for loop. Then we have our top tape and bottom tape, which we draw out onto the thing. And then to the right we have our scales and everything, and over here is where we actually get all the values and stuff. So this is what a glow script result is. As you can see, is the magnitude of electric force and gravitational force are around the same, and that should be true because it is floating. Some assumptions and possible errors include that there's no friction air resistance, the tape has evenly distributed charges, and both the tapes have the same charge. Some errors could be present were loss in charge due to handling, the measurements are slightly off. All assumptions may lead to errors in the real world scenario. So what if you had modeled each of your tapes as a single point charge, like in the previous lab? So in the previous lab, we had a value of 1.1 E8 around, and in this lab we had a value of 2.6 E8. As you can see in the second lab, we have a bigger value, almost double the value, and this is due to, and why do the estimates differ? This is due to the second one actually being a more accurate representation, as we're looking on the entire tape and looking at specific point charges on the tape instead of just considering the entire tape as a point charge. That's how we get out, we estimate the charges better using that. Thank you for listening to my presentation.